In this section, I will explain about the drift current. At first, let me explain about the drift velocity, the movement of electrons and holes. First, let me talk about the movement of electrons. In the electric field, the electron get the force, which is the Coulomb force. When the electric field, the direction of electric field is left to right, the electron gets force inverse direction to the electric field. So the electron can be triggered to right to left. However, when the electron meets the other electrons, it could be scattered. So it looks like a vibrating motion. So when the electron gets the force from the electric field, it moves like the randomic directions, like this description. As an expression of this movement, when, as I said before, the electron gets the Coulombic force, which means that is from the electric field. So the formula can be like this. Here minus means the force which the electron takes is the inverse, has the inverse direction from the electric field. And when we multiply the specific times of to this force, this F multiplied by times tau means the change of the momentum. So this can be expressed like the mass of the electrons multiplied by the velocity of electrons. However, in here, the specific times t is the called mean free time, which means that when the electron vibrates, meeting the other electrons, there should be some mean value of the times which the electron cannot wouldn't be disturbed from the other electrons. So this free E also means the specific meaning, which is that when the electron vibrates randomly, it has the mean value of velocity, which means that even though it looks like the electron vibrates randomly, it can be moved forward move forward to some value by the mean value, a mean value of velocity, which means this VE. This is called the root mean square of the velocity, and this is also called the drift velocity. Thus, we can organize this formula by the relation to the V with the electric field E. Thus, the VE can be expressed like charge Q multiplied by times tau over ME, which means the mass of the electrons multiplied by E. So here the coefficients of the electric field means the mobility called mobility. So this drift velocity is can be expressed to the multiplication of mobility and electric field. And also when we know this drift velocity and mean free time tau, we can multiply these two values, so we can know the mean free path. As I said before, in this movement, the electrons wouldn't be disturbed to the other electrons. Repeatedly, we can know about the movement of holes. The process is almost same to the electrons. The difference is the holes has the different mass to the electron, and thus it can be expressed to the different drift velocity and the different mobility, and also the different mean free path. From these equations, we can think about the drift current, which can be expressed to the and this drift current is expressed to the sum of the drift current of electron and drift current of hole. And also when we divide this equation by the area A, we can know the drift current density, which has the similar relation to the drift current. And as we know, this drift current density can be expressed by the charge density multiplied by the velocity of holes or electrons. So the drift current of the electron can be expressed like Q and mu n E field. And here this Q multiplied by n means the charge density of electron. And this mu n multiplied by E field means the drift velocity of the electron. And also this expression can be applied to the holes. So the total drift current density can be expressed like this. Here the coefficient is the sum of the charge density multiplied by the mobility of each holes and electrons. And it can be reorganized to it can be substituted to the same values, the sigma, which is the conductivity of the materials, which has the holes and electrons. Thank you.